Okay, we're going to look at horizontal and vertical lines here. Now, first thing to know is that for a horizontal line, the equation of a horizontal line is in the form y equals c, where c is the y-intercept of the line. And for a vertical line, the equation is x equals c, where c is the x-intercept of the line. Okay, so we're going to do some questions based on that, and you'll see why these equations are the way they are. So let's have a look at the first question. It says draw the line x equals 3. So straight away, as soon as we see x equals 3, we come back and we see that it matches this equation, x equals c. So we know that we're drawing a vertical line. So I'm going to draw a vertical line passing through 3 on the x-axis. Okay, so just grabbing a line there, and let's make that a little bit thicker. That'll do. Okay, so x equals 3. There's my vertical line. Don't forget to put arrows on the end of the line to say that it goes forever. So that's my line, x equals 3. It passes through 3 on the x-axis. So why is that equation x equals 3? Well, it's because every point on this line, every single point, I'll just color some points in here. Here are some points. Here are some more points down here. Now, all these points will have an x coordinate of 3. So this here is 3, 4. This is 3, 3. This is 3, 2. This is 3, 1. That point there is 3, 0. This point here, that is 3, negative 1. And then this point here is 3, negative 2. And this point here is 3, negative 3, and so on. Okay, so every point on that line has an x value of 3, and that's why we say the equation is x equals 3. Okay, now the other line we're going to draw is y equals negative 2. So if we go back to here, that equation fits y equals c, doesn't it? And y equals c is a horizontal line passing through c on the y-axis. So we just have to draw a horizontal line passing through negative 2 on the y-axis. Okay, so let me just rub some of these out. Here we go. Yep. I'll just rub this out as well. Okay. So we're going to draw a horizontal line passing through negative 2. Okay, so let's do that. Horizontal line passing through negative 2 on the y-axis. Okay, so put arrows on the end. There we go. And the equation of this line is y equals negative 2. Now, every point on that line will have a y coordinate of negative 2. So if I take this point here, coordinates is negative 3, negative 2. If I take this point over here, this is the point 1, negative 2. So every point on that line will have a y value of negative 2, and that's why the equation is y equals negative 2. Okay, now let's look at the next example. For the graph below, find the equation of the vertical line. Okay, so here's my vertical line here. So straight away, I know that it must be x equals something. And I know that every point on that line will have the same x value. Well, that x value in this case is 6, isn't it? Right, so it's going to pass through 6 on the x-axis. There it is. Okay, so the equation for this is x equals 6. Now for the horizontal line, we know that the equation of a horizontal line has this equation, y equals some number. Now, we know that number is the y-intercept, if you like. But every point on that horizontal line will have the same y value. So it means that this point here on the y-axis will also be -3. Okay, they'll have a y value of -3. So the equation is y equals -3 for the horizontal line there. Okay. Now, just as a bit of extra information, the y-axis, as we know, is a vertical line, and that has the equation x equals 0, doesn't it? Because it passes through 0 on the x-axis. And the x-axis, well, that's a horizontal line through 0 on the y-axis. So the x-axis, that equation is y equals 0. That'll come up later in the exercise. Okay. Now, last of all, we're testing for point lies on a line. So a point lies on a line if its coordinates satisfy the equation of the line. So let's have a look at our first example. Which of the following points lie on this line? So in other words, if I substitute the x value, here we go. There's the x value there. There's x and there's y. So if I put these numbers into this equation and get a true statement, then that point is said to satisfy the equation. Okay, so now let's have a look first. We're going to start off with, now the setting out is specific. In this case, we're going to have, I'm going to start off with LHS, which stands for left-hand side. Okay, so that equation has got two sides to it. It's got the left side and the right side. This is the side on the left of the equal sign, so call that the left-hand side. And this is the side on the right of the equal sign, so call that the right-hand side. Now there is a correct way to set this out, and it's got to be like this. So you start off with the left-hand side as x minus 2y, right? Which equals 17 minus 2 times 6. Okay, that gives you 17 minus 12, which is equal to 5. Okay, now is that equal to the right-hand side? Let's have a look. So right-hand side is equal to 5 as well. So we say the left-hand side equals the right-hand side. Therefore, 17/6 lies on the line. So therefore, 17/6 lies on the line x minus 2y equals 5. Okay? Now that's the way to set it out, left-hand side and right-hand side. So let's do part B. Part B has, we'll start off with the same way. Left-hand side is equal to x minus 2y. Okay, and this is the x here and this is the y. So we get 8 minus 2 times -4. Okay, which is 8 plus 8, which equals 16. And notice it does not match the right-hand side. The right-hand side is equal to 5, right? So our conclusion this time will be left-hand side is not equal to right-hand side, right? Therefore, 8 -4 does not lie on the line. 8 -4 does not lie on the line x minus 2y equals 5. So that's what you've got to do for those sorts of questions. The setting out has to be exactly the same as what I've done. Okay, so that is it for the theory. Okay.